Welcome to the another session, the short session, just to explain a little bit on how computers connect to each other and how you create a LAN and how you create a network in overall. So we're going to start with a blank page. We have nothing in the network. And I want to bring in a laptop. That's a single computer by itself. It doesn't do anything. Is just work locally and nothing else you can communicate with. I'm assuming there's no Wi-Fi. So I need to now, I want to network two computers. So I bring a second computer. And the next thing that I'm going to do is I want to connect them together. I want to create a connection between these two from computer A to computer B. They are connected, right? And right away, this is your layer one. So layer one is established between computer A and computer B. What's going to happen is that they're going to try to connect with each other, and they're going to try to negotiate an IP address. If they don't receive any DHCP response or any DHCP, Windows, Linux, Mac OS, and some other operating systems, they will default to the API-PA IP address. That will be in the range of the 169 or 254 that something is a /16. In this case, let's assume that I got a 135, and this is a /16 IP address. Then next, what's going to happen is that the other computer will do exactly the same thing. So it's going to grab an IP address by itself. Let's say this one grabs 75. It will self-assign the IP address and put it 27. So just by having the two computers back to each other like that on a point-to-point, and if you see with the subnet mask of 16, that as long as they match the first two octets, they are on the same network. Now this computer will start talking to each other. They establish the layer one, they establish a layer two because they have a MAC address on the NIC card. The network interface card is going to start communicating at a layer three, and now they find each other. They will do discovery because they know they're part of the same LAN. And I'm creating like a small line between these two computers, and they can talk to each other. If I want to expand this a little more, then I cannot do a point-to-point. Remember, this is very inefficient. So I bring up a switch. If I can bring a switch, and my switch, it is ATM switch, worker switch. I want to bring a switch here. I like the size. I want to make it more like the regular switch. I want to bring a switch like that. So this is a layer two switch. It could be anything between 8 port, 16 ports, 24 ports, 12 ports, 48 ports. And I'm going to connect now this computer not to there, but I'm going to connect it to the switch. And the same thing is going to happen with the other computer, right? I'm going to connect it to the switch somehow, and now they're connected to the switch. Now, I can go ahead and take this computer and self-assign an IP address. I'll do a static IP address. On the static IP address, I assign anything that I want. Remember that if I go to my computer and I do ipconfig/all, there's some information that I need. In this case, I need at least my IP address. I will need a subnet mask to limit how many computers and hosts are going to be on my range. If I have a default gateway, a router, then it will be it has to be provided. And if I have a DHCP server, then the DNS server, that'll be my DNS server. That has to be specified. In this case, we don't have a DNS. It's going to be a small network. And I'm going to self-assign IP addresses. So this one, I'm going to come and say, you know what? I'm going to create a network. I'm going to call it 10.0.10. And this was going to be 25. And this is /24. /24 means that as long as I match these 3 octets, I'm on the same LAN. And things I'm using, and this is going to be 184/24. Now, if this is a unmanaged switch, being an unmanaged switch, all the ports are basically on VLAN 1. on a network one. There's no definition, so they're always on the same VLAN. So this computer will be able to talk to each other as long as they match the same three objects, 10.0, that 10, 10.0, that 10, because it's /24, they'll be able to show each other. I can even bring another computer to the picture, bring a computer here. I'm going to also assign a static IP address, and this I'm going to call it if you can go all the way to the 254, I'm going to pick 210. And then, of course, I need to get my connector and connect this computer. Let's see, to the switch. If that's what everybody wants when it connects like that. Okay, so now I have all three computers connected like that. This is unmanaged switch. There's no VLANs, no anything, and they're able to talk to each other. They belong to the same LAN. So I have a LAN here, right? Now, what happens if I create identical setup on the other side to create a second LAN? So you copy this, I'm going to paste it here, and I'm going to change my IP addresses. I'm going to keep it still as a /24. Ooh, what happened to my IPs? They got all out of place. Okay. Something I love to get it. Okay. And this one, I'm going to create the network 10, network 20. This is 2049. This one happened to that I assign a 20 that 18 sounds good. And this is it's going to be a 20 21. So as you see, this with this mask /24, through this unmanaged switch, these computers are able to talk to each other, and these are able to talk to each other. Okay. Now, how do I get to have LAN A with a big A here? Make it big letter, bullet A. Didn't look that big. And then I'm gonna call it my LAN B. Okay, I thought it was a copy paste, not a move. So I have LAN A, my LAN B, these are all happy with each other. They all can talk to each other. All these happy with each other. They can talk to all of them. Do I need a gateway? Well, no, I don't need a gateway because all the computers are on the same LAN and they don't need to traverse any network. So what I'm going to do is that I need to introduce now another network component. That network component, it is a router. When I introduce the router is a device that allows me to connect LANs together. So I'm going to create a big router here, and this is my router. How do I do this? Okay, so what I have to do now is to create a connection to every a device together here. Let me get my connectors. And I'm going to connect this switch to that, and this switch to this. So now this switch is uplinked to the router, and this switch is uplinked to the router. And just for purpose of tracking stuff, I'm going to put here uplink, and to do. Wait. Whoa, things got reconverted. Hold on. Okay, perfect. So this is my uplink to the router, and this is my uplink to the router. So from the router point of view, this is called a downlink to the switch, a downlink to the switch, and this is an uplink to the switch. It's you're going up to the switch, because that's the one serving your area. So in order for me to have LAN A to talk to LAN B, I need a router, which is a layer 3. I need a gateway. If I configure these computers and then I tell them that they're gateway, just the same way that I have it on my computer, that I have a gateway that my computer is on 10.10.100, 10.10.132, and my gateway is 10.10.100.1, then I can define in this here that I'm going to have a gateway that is going to be defined at that location. And this is going to be the 10.10.10.010.1, and it's defined at this interface of the router. Likewise, I'm going to take this side, and here, the key is kind of jumpy. I'm going to define it as a 10.0.10.1, 10.0.20.1, right, as a gateway. So now, when these computers need to get out of their LAN to go from the LAN B to A, meaning from 10.0.20 to 10.0.10, then it will have the traffic the switch will forward it to the router. The router will receive traffic on the 20.1, will make the communication to the 10.0.10.1 gateway, and then send it down to the switch to see which computer you wanted to talk to. Okay, so the router now is aware of that. Now remember that when I connect these computers to the switch is going to learn the MAC addresses of these 3 computers. Likewise on DB. Now, when I connect this to a router, the router is going to create an ARP table, ARP, Address Resolution Protocol table, which is going to match the IP address and the MAC address, and it will identify also on which interface that is being seen, or where it can locate that computer. And that's how you can route from one LAN to another LAN. Why do I say route? Because you're going through a router to go from one LAN to another. Okay. Now let's mix things a little more. If we have a route switch where you can have routing and switching on the same device, so we're going to make this a route switch, and on this route switch, on another portion of the router, you define your 10.0.10.1, and you define your 10.0.20.1 as IP addresses at a layer 3 on this router. Then on the layer 2, we need to define your VLAN number, your virtual LAN. Now, in order to create VLANs or virtual LANs on a switch, those switch needs to be managed switches. So in a way, we're going to yank out this switch, yank out this unmanaged switch, and replace it with managed switches. Managed switches are the only ones that allow to have VLANs and to have multiple networks, and you can configure the ports individually for multiple networks. And also, these switches are managed. So I'm going to create another VLAN that I want to use for my management. And that one, I'm going to actually do things like /24, but I'm going to make it my network 100, right? And I'm going to call this one, I'm going to put it at the beginning, I will call it VLAN 10. This is, I'm going to call it my VLAN 20, right? And this one, I'm going to call it my VLAN 100. So that's it's going to be that's the gateway for that IP address. Now, since these switches are managed, now I need to create a managed IP address on those switches. I'm going to then put an on this uplink. I'm going to configure this interface, the managed interface, and make it into a 100 that I'm going to call it just 10. It's also /24. And then on the other switch, on this uplink, is going to be 10 that I want to call it 11. Actually, you know what? 11 and 12 for switch 1 and switch 2. Okay, so these are managed switches. They support VLANs. And now I need to start tagging VLANs on this port. So this port here is going to do encapsulation. So when I do the encapsulation there, it's going to do a this way encapsulation. And remember, it was 802.1q. And I'm going to add here my VLAN 100. Why? Because I want to make sure that this VLAN 100 gets propagated through this downlink and it gets to the management of this switch. So I can get to the 10.0.100.12 and configure this switch. I'm going to go to the other side and I'm going to do the same thing. And it actually, I don't have to do anything different. It will be exactly the same, which will be encapsulation, that 1Q, and it will be VLAN 100. So now, since VLAN 100 is defined on this connection here on the uplink, I can get to 10.0.111 and I can manage this switch. Since I'm managing this switch, then these computers are all on the same network 10. So what I need to do, well, in here, I'm also going to add my VLAN 10. And on the other side, I'm going to add the VLAN 20. That's good. That's fine. You just bring it down. You can see it. This is just going to make it this way. That's good. So VLAN 100 gives the management to the switch. VLAN 20 makes the connection to this here. Since this switch is managed, now we need to identify every single port to what VLAN they belong to. So on this side, sorry, this side, I need to define that these ports belong to the VLAN 10. So I'm going to define on this switch by the management interface that these ports are on VLAN 10. That way, this 10.0.10.184 gets encapsulated with a VLAN tag of 10. It goes to the uplink that has 10 and 100, and they reach the 10.0.10.1 gateway. And then on the other side is exactly the same thing. That I'm going to have the VLAN 10, but VLAN 20. Okay. And this port is also on VLAN 20. And this port is also on VLAN 20. So everybody's happy. All these computers are on the 20 network. The port is accepted as members of the network 20, right? And they are able to reach through this link that is trunk yes, it's a trunk port with encapsulation for VLAN 20, and they reach the 10.0.20.1 network. That's how they can reach now that one, because this is a managed switch. This is a managed switch, and now we're supporting VLANs. We're supporting multiple networks on the same switch. Again, everything will work exactly the same, but once you define a VLAN on this port and you create VLANs here, then you have to define that this port belongs to VLAN 20, so they can talk to the 20.1, and this belongs to VLAN 10, so go to the VLAN 10 gateway. The advantage of now trunking with this trunk port is that, you know what, let me add to this port. I want to add more VLANs on it. And I want to add this, on this one also VLAN 20 as part of the uplink. And on this side, I'm going to add my VLAN 10. So by doing that, that VLAN, or that network 10 and that network 20 gets propagated to the switches. And I remember, when I define this on this side, you have to define the same thing on the other side. It's not just on one leg. It has to be defined on both ends. They both have to be on the same page. So one define that. So now VLAN 20 resides here, but nobody's using it. So all I need to do is take one of these computers and literally drag it to this side. And this connection that is here, I want to say, I'm going to plug it into a port here. And this port is going to be on 20. As per this computer, right? As per this computer, he's still connected here on this LAN, on the LAN 20. It's still in the same place, and nothing has happened. He still needs to reach. He can reach the 20.10.0.20.1 of the router and go to any other network, or as a layer 2, I can go through this 20 on the uplink that is on 20, go layer 2 of this switch, because I'm not touching layer 3 and not going to the gateway. Then on this, come down on this port that is being VLAN 20, go to this switch that also has VLAN 20 and talk to these computers. Remember, the MAC address table is fully populated on this router here. This router knows every MAC address. So the moment I move from switch A, B to switch A, and I connect this computer and attack the port on VLAN 20, then the address table here goes, oh, so it's not this way. Now I see it this way. And it knows to send it to this switch. The switch is the one that knows exactly what port you're on. But the switch, the router knows, so you go through this uplink to the switch. Now I'm going to do the same thing here. I'm going to take this computer, I'm going to move it to this side, and this connection that was on that switch, I'm going to move it here. Now this is 10, and I need to configure the port as VLAN 10, and the IP address moves over too. So now he's on VLAN 10. He is attached to the network 10 on this port, and then from here, go to the uplink on the VLAN 10, the layer 2. I can go across layer 2 down over the VLAN 10 tagging and talk to this computer and talk to this computer like if we're still together on the same switch. Now, this can be across buildings. This could be across floors. It doesn't matter. But the nice thing about this is that if this is the first, A is on the first floor, no, A is on building A and B is on building B, and I got Bob that used to be on building A, and I want him to move to building B for whatever reason. I don't know. He's handicapped. There's no elevator, and the office is here on the second floor. These offices here are all on the first floor. I need him to be on the first floor here. So I'm moving from building A to building B. I connect it to the switch. I tag the port, tag the port itself on VLAN 10, and that's how you get to this state network to communicate through the uplink, through the router to all this state network. And I can get any other. If I create a new network, and I want to create a new network, and I'm going to call it not going to be 30, but I'm going to call it a 50. So it's going to be 50. It's going to be VLAN 50. Is 10.0.50.1. It's configured on the router on the layer 3 side. And this time, you know what? I'm just going to put one on one side. I don't need it everywhere. I just happen to only need it here. So I'm going to add VLAN 50 to this uplink port. So now I'm sending VLAN 50 traffic. Did it move so much? I think it was the line that moved. That VLAN 50 traffic to this switch, but I have no ports on it. So I'm going to create I want to get a computer. And I'm going to copy this and clone it and put it here. And let me get a connector. And I want to connect it from here to this switch. Hopefully it will stay there. Perfect. Now this port has to be on what VLAN? What VLAN 50? And he's going to have an IP address that resides on that network. And he's going to be 50.113/24. So 50.113 can come to this stack traffic, to take stack port, and go through the uplink that I have VLAN 50 on it, and then he's able to communicate to 50. So let's imagine this network. Do I have a network symbol for the internet? No, I don't. Let's see. No, I don't. But let's say this router connects to your AT&T network, It's a little bigger. That's AT&T, and AT&T is the one that provides your a connection to the internet. There you go. So now this is connected to that, and this is your provider or your ISP. And then this has for the rest of the internet. So this computer on 50 can get to 50.1, and if it needs to go to a network that is not here, the router most likely will send it out to the AT&T. Because, well, if it doesn't belong to any of my internal networks, then it must belong to the outside. So it will send it out to AT&T, and AT&T will figure out what to do with it. And now I have a single computer on a single network, and that it can go out to the internet. At any point, I can add more computers on 50 here. I can add a computer here on 50, and all I need to do is take that computer, put it there, plug it into a port on this switch. I don't like the connector. Come on. Oh, yes, behave nicely. Doesn't want to behave nicely. Okay, I'm gonna have to move this one. No, it doesn't want to move either. Okay, so this is the one that was on 20. And now I'm gonna create this one is a port I have to define on the network 50. And then I'm gonna give it an IP address that is gonna be on the 50 network. And I'm gonna call it 50 that I don't know, 17. Well, 217 is fine. So, whoa, it moved all the way here. It has a binary zone. Anyway, so this is the one on 50. And this is the one on 10, so it's a little bit more clear. Okay, so he will connect to a port that is on 50. It goes to the, this is not gonna work right now because I never put the VLAN on the uplink. This is gonna get here, it's gonna get tagged, and then when it gets to the uplink, it goes, well, I don't have 50 tag on the uplink, it's gonna stay local. So all I need to do is to add it here. So now there's traffic being tagged that goes through this uplink for 50. Remember, this is the configuration for this port. This is the configuration for that other port going to this uplink. What about that VLAN 100? The network 100 for management, does it need to go anywhere? Well, no, it doesn't. It doesn't have to go. That 100 is only for management, and the management goes only to the switch. It's internal to the switch. The same thing with this one. The VLAN 100 goes here. Now, I could have another switch cascaded from this switch, and then I need to put a link, another downlink to an uplink, and then add all the networks there and include the management if they're tagged together. So if I have another switch that sits somewhere in the bottom here, and let's say that attached to this one, and I want to connect it from here to here, that didn't work out too well. Yeah, here's the binary zone. Then yes, I'll have to put that VLAN 100 on that link here. And then I can take on this uplink and, okay, grab the wrong one and put it back. And this switch is going to be a 13. Okay, so now this is switch C. Now I have switch C that is 10.0.113. I don't have any other networks. The only network that I'm sending to this switch is 100. So 100, 10, 20, and 50 go from the router to this switch. I'm sending those VLANs here. I'm connecting those, tagging together or trunking. Either way, use tagging or trunking. It's the same concept. And then from this guy, from this switch A, I'm going to send it to switch C, but only now VLAN 100. So I can manage the switch, but I don't have any computers added to it. But now I have at least the least that I need on this switch is the management. Management doesn't go on any other port because it's only for management. But now from the 10.0.100.1, I can get to those switches. So if I'm in 10.0.51.13 and I want to SSH to 10.0.113, I go through this port that is going to tag my traffic on 50. It's going to the uplink tag with 50. So it is on that trunk, on that uplink port. It's going to go to the switch. It goes, hey, 10.0.51.13 wants to talk to the switch on 10.0.113. So this router is going to make the connection between VLAN 50. It's going to route the traffic to the VLAN 100 for the 100.1. He's going to look at his ARP table. He goes, where do I see that IP address and the MAC address that correspond to that device? And it says through this uplink. So I send it to the switch. And the switch said, well, it's not on my ports here, but I have another port that is uplink and another switch, and I see that MAC address, an IP address on that link, and it's going to send it down that link that is tagged on 100. So it will send the 100 traffic to here. Remember that when I do the jump here in the router, my 50 network traffic ends right here on the 10.1, and it jumps over to the 100 network. So everything here is network 100. It goes to the VLAN 100, it goes to the VLAN 100, and it gets to the switch that is on 10.0.100. Okay, it's jumping over from one network to another, but that jump is done at the router. It's not that I go 50 and it goes 50, 50, 50, and then 50 somehow gets converted to 100. No, traffic leaves 50, goes stack into the switch, goes to the uplink, the stack with 50, and it reaches the gateway, the 10.0.50.1, which is the gateway for that, like the doorway to get out of that network. Then I go into the 100 network, and the router is keeping that connection. It's now when you look at the headers, when you get source and destination, all that header is stored there, all that information. Well, I don't want to extend this that much. It's getting close to 45 minutes for this short explanation. But that's how VLAN trunking and networks and how things start get popular and created and things start to grow. Now, imagine this having a router with 100 switches, and those switches can be cascaded with other switches. So you can have 200 switches and all connected to one router, multiple networks. I remember that each network, if it's a /24, can have 255 endpoints, the devices, including the gateway. So you can have thousands of devices on one network and all handled by one router. At the Kendall campus is one router that handles multiple buildings, multiple floors, and each building and each floor will have a switch like this and different networks associated with computers around that area. Okay, thank you for staying this late. Thank you.